should
came
say.
in and got your name tag, there's this piece of material that has a CD in it. So before you leave today, be sure to pick one up because the CD has all the presentations. And it has a lot of ASDSO brochures and stuff, so it's a very good CD of not only our stuff, but all the pamphlets and stuff from ASDSO. So it's at the back with the name tag for it. Also, the engineers in the audience, particularly if you want a professional development hours certificate, be sure to pick one up also where you got the name. It looks like this. So we've got 4 presentations, 2 before the break and 2 after. And then following our presentations, there's 2 of them talk about possible funding from the state and the NRCS. There'll be a couple short presentations we finish to wrap things up. We've got a lot of questions. We're kind of sorting through those. Some of those we'll try to address during the presentation, just part of our normal talk. And then some at the very end, we'll read them and try to answer those. Now, what you're going to find with a lot of these presentations, there is some redundancy when we talk about maintenance, operation, repair. So you'll see some of the same discussions. And it's important because we want to reinforce them, particularly those that are really important and those that are critical. So in this session 4, we're going to talk about dam operations, maintenance, and inspections, because you as dam owners are going to be doing most of the maintenance and you're going to be doing most of the inspections. And when I say inspections, it may not be as formal as filling out a checklist, but every time you walk the dam, it's theoretically an inspection. Use your eyes, use your feet, what you're looking for, and you don't have to so much document it, but just observe what you're doing when you're walking near the dam. What's generally talked about, we always have about earth fill dams, not so much concrete, but there will be the concrete spillways we'll talk about. Our different types of spillway system, the outlet works, the conduit, and just a little bit on concrete dams. Cannot overemphasize whose responsibility it is you as a dam owner. There's a lot of assistance people can provide you, a lot of people can answer your questions, but it's your dam, it's your liability and responsibility. And keep that in mind, because the dam where the fail, you may not ever get it back, so your home bags and property bags are going to drop. So it's important to try to keep a good, safe operating dam at all times. O&M is just like taking care of your house. You know, if you don't repair a leaky roof, it's going to do more damage. And the dam is no different. You know, if there's a problem with it, nip it in the bud, try to correct it as soon as you can. You know, whether it's just repainting something or having to come out and fix somebody, there's some small concrete to repair that. So even though they appear to be very minor, they will get more expensive just with time. And change what it says. All right, talk about just some dam operation itself, record keeping. And the main thing with that is if you have instruments, and you have toe drain outlets, if you measure a depth, what you want to do is record, all right, what was my lake level that day? You had that rain snippet, but if it's some kind of long, heavy rain, it will affect the instruments a little bit, so you want to indicate, all right, hey, it rained 3 inches over the last 3 days. Measure your toe drains and be sure if there's more than one that you label them and say, here's the flow rate. And all you have to do is take a stopwatch and graduate it to a small bucket. Usually these drains are going to be in small gallons per minute flows and measure them. And a lot of the time what we do, we'll measure them twice and take an average. And then just record them. Keep a log that you can keep track of all the readings. Your emergency action plan. Once you develop one, it's a living document because people's names and their phone numbers change. So at least every year, make sure the contact information is the same. And if it's not, then you update it. And when you update it, make sure you send that new information, and Joe will touch on that, to everybody that has a copy of the plan. Doesn't do any good if you're the only one that has the correct phone numbers and nobody else has it. Downstream development, again, you may have right now just one house below your dam, and your EAPs may have just a contact information for the owner of that house. But now they're going to build a subdivision downstream. Now there's going to be 30 houses. So now you've got to update your EAP, you have to update your inundation map. So now the emergency responders know who they need to evacuate if they get a phone call. So what we found with some counties are useful, is that we provide them a breach zone map, and they try to limit development in the breach zone. Now, we all know land rights is a hot issue. You know, it's my land, I can do what I want to with it. But these counties try to generally persuade the developer to make sure the houses are built above a certain elevation. But you got to work with your local land development companies, city and county authorities, to see if they will work with you to limit development in the breach zone. Particularly if you have a significant low hazard dam. You don't want your dam to become high hazard. Public safety, just as I mentioned before, lakes are an attractive nuisance. Spillways, you want to put signs, you want to put gates, you want to put locks on, or try to limit the kids coming out there and playing at your structure. It's just something will happen. Eventually, somebody will slip and fall and you'll get sued over. So, and Joe talked on this about the legal aspects, about, you know, if you don't have signs, you don't have gates and stuff like that, the lawyer's going to say, well, you invited the kids to come here. You know, you didn't do your due diligence to minimize them being attracted to your lake and spill. So here's just simple signs. Sometimes, and you'll see these bigger lakes, they'll have warning systems below the dam. But these big hydropower facilities, when they generate power, they release a lot more water, and there may be fishermen or people kayaking. And I know a lot of these big power companies will have audible alarms, you know, that they'll sound off before they start releasing water. So it's really the big boys that have to mainly worry about downstream. But you do sometimes a simple sign of keep off, danger, something like that near you, particularly the spillway, to make sure people aren't playing around the spillway. Operation of drains and siphons. As I mentioned before, if you have a gate, you don't have to open it all the way up and close it. You generally just want to crack it to make sure it's not frozen. Because sometimes if you open the gate, you can't close it, you end up draining your lake and killing all the fish. But you want to make sure it's not frozen. If you have a siphon, periodically start the siphon manually. Make sure it's still working. You know, they're designed such that you can bring a small pump out, charge the siphon up, and get it to run. Let it run for a minute, shut it back off, and take everything good. If you find one of these, like a siphon or a drain or a gate that's in such bad shape, you need to get an engineer to evaluate it and get it repaired. You know, if you got a spillway gate and it doesn't work, and then you have a flood, and you got to try to open it, doesn't work. Again, that's going to be a legal responsibility. The facts will come out. If you had a gate that didn't work, it could maybe prevented your dam from failing, but it did fail and it killed somebody. So, as Jill mentioned, between maintenance and repair, a gate probably falls under repair if it's a big enough gate. Just keep that in mind. As I mentioned before, the gears on these are such that it doesn't take much to open up the gate or close it, and you can easily open the gate, but you damage the gate by trying to close it. So during a big storm event, when your lake goes up 3 or 4 feet, it's something you want to look at the dam immediately after the storm, because there may be a crack in the dam that's above your normal water level. It never sees water. Now your lake went up 3 or 4 feet, and water is now going through the crack that you never knew before. So always after an elevated pool level, come out and check your dam. Not just the top of it, you got to walk downstream, also. Immediately remove any floating debris, because eventually those personal spillways create a current, and all that's going to be eventually attracted to your spillway. And if you got a good looking functional trash rack, that's great. But the trouble is all that trash is going to build up around your trash rack. So you got to keep that unit pulled off also. Instrumentation systems. I've seen where people are out mowing the grass and they just run over an instrument. They don't know it's there. There's not a marker. So you got, if you do have a monitoring well, an observation well, put a marker next to it so the guy, particularly if you hire out the mowing, that they just don't run over and knock off the top of the instrument. Some dams, not many, where there's a hazard immediately below the dam, where I've had people install an audible alarm where if the water in their lake or spillway reached a certain level, a siren would go on. Because the house was right there below the dam, the hazard. So if you have something like that, and they are useful at times, make sure it works. You got to test it. If it's got batteries in it, it's got to have a battery backup. You got to test those and make sure they work. Anything electrical, mechanical, you need to check on. Then wildlife control about burrowing animals. As soon as you see one, capture it. Now some municipalities have regulations on killing animals. You may have to capture them and go release them somewhere. Joe mentioned vegetation, particularly along the water line. Those animals like that cover, protection. So if you remove it and keep it cut, those animals don't like that. So they'll generally stay away. But if you let it grow up in bushes and tall grasses, they love that habitat. Showed you this one earlier. He looked like he's struggling to close that gate, but you could actually take one hand and close it. One thing to keep in mind is, particularly for stuff like vandalism, is you take that gate off, that handle, or some kids will come out there and drain your lake. So, but you need to know where you put it. It's kind of like in your house, you say, I'm going to put something over here so I don't forget, but then you forget where you put it. But don't leave it on there, because even though in this case you got fences and all, kids will come in there once they figure out what it is and start draining your lake for you. Here's a monitoring well. Here's one that's sticking above the lake to the ground, so that one you don't have to worry so much about getting run over by a mower without knowing it. But it has a cap on it, and it will have a lock on it, because otherwise, if you don't, you'll end up finding beer cans and rocks and everything else thrown down there. Next thing you know, your instrument doesn't work, and it's $5,000 to replace it. So put a cap on it. And in this case, make sure it's not at the ground level, because you don't want rainwater giving you a false elevated reading. So you have it above the ground, and you have it where it's locked and secured. Dam maintenance. Depends on type of the dam, but we're going to mainly talk about Earthfield Dam. The watershed characteristics, mainly if you're on a large watershed, during the floods, I mentioned before, expect a lot of debris coming down into your lake during the flood event. If you're on a small one, not so much. Spillway systems, we're going to talk about mainly the concrete spillways. Concrete, if it's new concrete, it may last 100 years. If the concrete that was placed 30, 40 years ago, they did not have air entrainment during that time, and old concrete was subject to freeze-thaw damage. And that will eventually, over time, actually destroy the entire concrete. The best thing you can do, one is not have any trees on your dam, but once you get a grass cover, is keep it mowed. And not mow it once a week like your front lawn. It may be only 3, 4, or 5 times a year. But you just don't want it to be 18 inches high where you walk out there and you can't see cracks, you may not be able to see the seepage, and it's just more attractive for burrowing animals. Small trees, say under 4 inches in diameter, I cut them flush with the ground. Don't worry about those roots. So anything brush and small trees, just go out this weekend and just cut them flush with the ground. Anything bigger than that, you start getting with bigger root balls, and you need to take those up, and that gets into a repair where you need to go through the permitting process. If you got an emergency spillway, or if your dam were to overtop, you create some gully, immediately get those filled in and get grass reestablished. If you leave it, you get another flood event, all it's going to do is get attracted to that gully, and it's just going to get a lot bigger and a lot faster. Same with burrowing animals. Trap them and then fill in the burrowing holes. Again, the grass, you can't beat a well-maintained dam. Not only, the main thing, it just helps you with inspection to be able to spot the problem early in. I had a gentleman during the lunch break say, all right, what if we're removing trees, big trees? Now, if the dam is, say, 15, 20 foot high and it's covered with big trees, by the time you take the trees and stumps off, you're going to rebuild the dam. I mean, you're going to take it. Now, if the dam's 25, 30 feet high, yeah, you got to bring in a lot of dirt, but you're not really starting from scratch. But eventually, those trees, the big ones will blow over and the roots will die. For these smaller dams, I guess the urgency is you should do it now, but you got to keep in mind, you're going to be rebuilding your entire dam by the time you get most of the roots off. Now, when you take out a stump, we're not telling you to go trace every single root out, because those roots may go 30 feet in each direction. You're going to get the main root ball, the major roots, and then you're going to put compacted earth back in the hole. Yes, you'll have over time those small roots will rotten out, but that's generally not been found to be a problem. It's the bigger ones that you want to try to get out and put compacted earth back. Now, obviously mowing on a slope can be difficult. They do make slope mowers. They're not cheap. They have it where you can mow fairly steep slopes with them. So this is a good example. I mean, you know, that's probably 3 or 4 weeks of grass cover, maybe 5, and that's fine. And then you come out and mow it fairly close. And after you mow it, you as the dam owner should inspect it. It's a good time when the grass is at its lowest when it's mowed to go out and walk the entire dam. When I say that, you not only walk the crest, you walk back, you know, about every 10 feet vertical, you walk back and forth along that slope, not just at the top and the bottom. You want to walk the intermediate part. Sometimes it's hard to find an animal burrow hole that's only 6 inches in diameter or a crack in the dam. You got to walk back and forth. Your feet will hurt because you're walking one leg higher than the other for some long distances, but that's what you got to do to do a thorough inspection. About all the trees and woody vegetation, you can imagine along the water line, that's just perfect habitat for animals want to burrow in. They burrow in right above the tree and go down and then come back up. So their entrance is below the water level, but then their den is obviously above the phreatic surface. Talk about floating debris. You know, big enough watershed during the storm, it can really clog up the spillway. Here's the inlet. Again, the amount of debris, they just need to come out there, remove it, burn it, all of it off. Don't push it to the side because it'll come right back. But remove it as quick as you can. If your dam were to overtop, or just the grass should die, again, go back in, treat it, plant grass, fertilize your dam if you need to, because you want that turf to be a dent. But if your dam were to overtop and your grass is a dense cover, as I mentioned before, it'll take a foot of overtop. But if you get bare areas, those will rapidly erode. That's where your failure will start. Here's again, here you can see the grass here, unless you just happen to walk by and step in it, you may not see that animal burrow hole. That's why it's important to keep the grass cut. Beaver activity. Block your spillway, as Joe said, they don't like moving water, and that's generally around your spillway. Here's one where you build a fence enclosure to keep the beavers out of the spillway entrance. And then, kind of a rule of thumb is if you got a entrance here, you excavate it, and then you can compact it with cementitious grout or compact it earth back. But you need to close off as much, not just the entrance way, you need to get the entire, but best you can, the entire cavity. So if you look at trees, again, if the trees are die or they blow over, you got that issue, you got the animal burrows, both maybe upstream and downstream. And then when you have that, you're going to maybe have a slope failure, so there's a lot that can go wrong with your dam. But 95% of the problems occur because you got bad vegetation, you got animals, these are mainly for small dams, animals in your dam, some seepage, and you don't maintain it. That's just a recipe that eventually that dam's going to have a serious problem. And the serious problem generally is creates either those animal burrows connect and you have a piping failure, or you have a slope failure. So cannot overemphasize maintaining the dam and inspecting the dam. Talk about your gates, exercise the gates. Metal components will rust. And if they rust, they'll bind up. So anything that is painted and is great, the paint is peeling off, you need to repaint it. If you got concrete spillways, most, at least the new ones, have joints in this spillway. The old ones don't, but they're going to crack. And a lot of times grass and small bushes will start growing in those cracks. And the water gets in the crack, water gets under the spillway. So if you have those conditions, sometimes minor cracking doesn't hurt a concrete spillway. But if you got a crack, you don't want water getting under the spillway. So those, clean out the grass, clean out the roots, and then you can get these sealants that you can make the caulking like you do around a window and caulk those cracks where water doesn't get in. Now there is a point where if you got a number of cracks and the cracks are rather large, then you have a structural problem. And we showed earlier these spillway slabs will crack and can actually come apart during a flood event. But the big thing is these minor ones, keep the vegetation out and keep them sealed with the caulking. You can go to a concrete supply store and get the right material to caulk a crack in the concrete. But like a lot of repairs, 90% of it is prepping the surface and then put the caulk. If you put the caulk in an unprepared surface, that caulk will come out within a year. Spall concrete, small pieces of concrete coming off is no big deal. When it starts exposing the reinforcing steel, and the reinforcing steel starts to rust, then you start using you start losing the structural integrity of the spillway. Particularly that steel's there for a reason. And if it's rusting away, then your concrete's not going to support the load that it was originally designed for. So you want to protect that steel more than anything else. And then repair, we talk about erosion. As soon as you start having a gully, fix it as soon as you recognize the gully is there. We talk about drain. Usually these drain gates are fairly robust, cast iron or steel, but it is metal on metal. So if both of them rust, they may bind and rust together. So exercise them just that little bit to break that rusty seal at least once a year. These metal components, this operator, some of them you have to lubricate and do that periodically. And if it's rusty, you use the gate stem that, clean off the rust and paint it, just like any metal thing. Otherwise, if you don't, it will slowly deteriorate and you'll have to buy a new gate operator. This guy repairing a concrete spillway. He cleans out the crack and then he uses the right material to repair the crack. The spillway where they need a little work, you see there's some joints and there's some cracks and you see the grass growing. And you see there's some caulking where they have tried to caulk those in the past and they did not do a very good job cleaning it out. They kind of mowed the grass and put caulk over the grass. But that you really need to clean out those joints, the full depth of the concrete, and then put it in your compound. This one has a void. You can put a steel rod at some of these joints and go down like 18 inches, knowing, all right, there's a void under this concrete. This spillway is about 40 years old, and now the water's gotten through the cracks and washed out some material. This one has fall concrete. In this case, the reinforcing steel has not been exposed yet. Usually concrete is 2 or 3 inches of what we call cover before you get to the steel. But that's getting bad enough. Eventually that needs to be sandblasted and repaired. But it's not long before you're going to start seeing the reinforcing steel, and then the corrosion will start. Again, embankment erosion, the extreme case of it, we repaired. And a lot of times when it's that bad, it may not be a wheelbarrow and a shovel. You may have to get a guy that's not this big of a case, but a dozer to come in there and reblade everything and then regrass everything. Nowadays, I know Schnabel likes on particularly new dams is instead of trying to get a contractor to grass a 3-to-1 slope and then getting back to come when the grass doesn't grow very well, we're specifying sod on dam slope. You've got immediately grass cover, and you don't have to worry about erosion. So maintenance of outlet channels, we talk about instrumentation, upstream wave protection. If you have a big enough lake, as I mentioned, and you get a storm and you get waves, it does create an erosion problem. You need to repair it. A small lake, you just fill it in, and again, you may have to lower the lake a little bit and get grass to regrow, or you bring in riprap along the upstream coast. So here's an outlet channel. The velocities of the water was too great and created this big erosion gully. Here's one where you do have riprap. This is a large lake. When you get on these large lakes, the waves can be 3 or 4 feet high, so they can do a lot of damage if you got a large enough lake. You got a dead tree, go ahead and remove it, because the roots are dying. The tree will die before the roots, but as soon as you got a dead tree, you need to go ahead and remove the tree and have somebody come in and dig up the stump and put in compacted fill where the stump used to go. Sediment at inlets, if you've got a lot of sediment coming in, particularly near a spillway, sometimes that sediment will start blocking the entrance of the spillway. So if that starts to occur, you need to get a guy to come out and dredge and remove that sediment. And this is kind of important, is the only way into, say, your dam is across a small bridge across a gully, and that's subject to getting washed out during a big storm event. Nobody can get to your dam. So you got to look at, all right, if I got a big storm event, how can the people I need to try to save my dam get to my dam? Is there an alternate route, or what do I need to do to guarantee that I can get contractors in the middle of the night to my dam? So you got to kind of think through the access during an emergency situation. Inspection. You know, you look for most problems are obvious. Not all, but most of them are obvious to the naked eye. You kind of generally know what to look for. You know, is water coming out of a dam, like even though they all leak, we try to collect the water. But if it's coming out of a spot you've never seen before, it could be a problem. Joe mentioned when you have a pipe that's too small to crawl up in, every few years you need to get the camera inspected to make sure it is not collapsed, if it's corrugated metal, if the metal is not rusted completely away. And I don't overemphasize these pipes. You can't inspect the inside. So the sewer contractor, everybody has a camera that will crawl up the pipe. And it's not that expensive. And it's really worth the money. And if you got a corrugated metal pipe, every 5 years you should have a camera going up the pipe. You know, your inspection will decide, you make a list. Okay, I need to repair this gate steel. I need to paint this. Or I got some falling concrete. Make a to-do list. Say, all right, here's what I need to accomplish over the next year. You obviously read all your instruments and you record that data. That's important because what we look for is trends and data readings. An individual reading doesn't tell us a whole lot. We're looking at, all right, what's happening over the lifetime of that? Is the trend going up or down? So you got to have that data and get a piece of graph paper and just plot that. You know, my tow drain number 1 was 1 gallon a minute, 1 gallon, now it's 5, back to 1. You get an engineer looking at that report, and he's going to look at your inspection. And he sees that spot 1 and it was 5, either there's a misreading or there's something going on with your dam. So that's valuable historical information, helps us engineers understand your dam. So we're looking at it at one point in time. We want to know what's going on for the previous 30 years. And you've got to document that so we know what to look for. Stability of a dam, you know, your slope was built on a 3-to-1, you mow it, it looks very nice. Then you go out there and look at it and you see a little hump somewhere that you didn't see before, or a little depression. And that's all in your eyeballs. And the grass is tall, you can't see it, but that kind of tells you, or you have the start of an instability problem. You know, it's going to be a slow movement, and if you catch it early enough, you can save your dam. We talk about the seepage. Look below your dam, look at the abutment contacts in the natural ground. So that water is going to find its weakest path, and it may not be through the dam, it may be around the dam. So we got slopes, this is an urban dam, slope stability. Do I have wave erosion? How's my seepage doing? Do I have it? Should it change? And then if you got woody vegetation, because a lot of times if you got a seep area, the vegetation is going to be different. It's not going to be fescue grass growing. It's going to be vegetation that loves that saturated ground. So that'll one tell you before you step up to your knees in wet mud. You can look at the vegetation, see willows and stuff like that, weeping love grass. You say, all right, I got a wet area. Look at this vegetation. And then at that point, you may have to put in a drain system to relieve that wet area. Maybe a minor drain system, but if you got a wet area, a lot of times it prevents you from doing the adequate maintenance of the dam if you can't mow it because it's too saturated. So here's if you saw this, you would activate your EAP because that is a significant failure of the slope of the dam at the toe of the dam. This is a shallow one, at least, you know, it's hard to see, but you can see usually it's a little vertical scarp, and usually there's a bulge at the toe. It's just that little wedge slide. And that's, once that occurs, the next one's going to be up a little higher, and the next one a little higher than that. So you see that, that's when you need to have your engineer come out and see what's going on. If wave erosion is left unchecked, well, we work this way all the way across the dam, but that usually takes a long time. But you can see there's a start. You got, that used to be a slope like this, and now you got an 18-inch vertical thing. If it's not repaired, next year it may be back here and then following year. So that's a maintenance activity. Catch it early, and you won't end up being a big problem. Show you pictures of seepage all day long. Obviously here, coming out at the toe of the dam. Here, water coming out of the abutment. Here's the dam up here, but now the water's coming around the abutment. So in this case, you may not lose the dam, but you may lose the reservoir. It may end up water draining out the abutment contact. Showed you pictures of boil. That is a problem that needs to be addressed immediately. You got water boiling out and carrying material. That is an immediate action to keep the dam covered. That is a dam. There's a lake over here. So many, I'm not about sure yours, but when I looked at Georgia Safe Dams program when it first started, probably 80% of the dams looked like that. A lot of people didn't even know they owned a dam. They knew they had a lake. Nobody told them there was a dam because it was all grown up just like the shoreline. And you see the size of the tree, that's a fairly narrow crest, but that's not uncommon on a lot of dams. So inspecting for wildlife damage, sinkholes, a lot of times if you got a metal pipe to the dam, what I do is walk upstream to downstream, because if that pipe is deteriorated, you may find a small sinkhole above the pipe. So pay special attention walking the dam where that pipe goes under there, because sometimes a small sinkhole will develop, and that'll give you a early warning sign there's a problem with the pipe. Cracking, we don't see it a whole lot, but they are serious if you do see one. If the crack runs parallel to the top of the dam, that gives you a sign of instability, that the slope's starting to move. If it's transverse, which we don't see a whole lot, but if it is, that's a serious problem. That's where water can go directly from the lake to the back of the dam. Talk about vehicle ruts on top of a dam. What's bad about dams, they hold water, and they just keep saturating the dam. And if the ruts are big enough and hold enough water, it can cause an instability to the downstream slope. It gets saturated. Even if you got a drainage system, the drainage system is way down in the dam, but these ruts are saturated on top of the dam. So if you got ruts, you want to fill them in so they don't just hold water and saturate the dam. Here's a groundhog hole. Like I said, walking the dam, a lot of times if the grass is laying over, you won't find this thing stepping. And a good indication is not so much the hole, is the debris trail. So they just push it out. So sometimes it's easier to see this than actually seeing the hole itself. Here's a sinkhole where a lot of times you'll find them over the top of pipes, particularly corrugated metal pipes that don't have water tight through them. So cracking, sparse vegetation. We're talking about the vehicle rut. They can just, if you have a lot of rain, fill up the water and really saturate the top of the dam. So on spillways, we showed you before, earthen spillways, they're designed to be damaged during your design storm. You get a big enough storm, they're there to prevent your dam from failing, but the spillway itself will suffer damage. So here's one that has a concrete weir, but it's in a rock channel. If you're fortunate enough to have rock, that is very forgiving in most cases. But here's one you see with rock. It's highly weathered, highly jointed rock. Now the spillway channel, which used to be up here, is now about 8 feet down. And it's starting to undermine the spillway. So while rock looks good and hard, in this case, you see how fractured it is, how weathered it is. Big enough storm actually removes a good bit of the rock. Here's another rock spillway. You will, with a big enough flood, you will get the loose rock and the jointed rock to be removed. Another picture of a nice grass growing in the concrete spillway. Some delamination, very poor condition spillway. I'm sure this one does not have air entrainment in it. Just got a lot of freeze-thaw damage, cracking, missing concrete. Probably should be replaced. In another presentation, it was in the news at Oroville Dam in California. It was in the news, the tallest dam in the U.S. The dam was fine, but the spillway operated and washed out, how many 100,000 yards of earth and rock. There's a picture in one of these presentations. But that spillway, even though it was one of the biggest dams in the biggest dam in the U.S., that thing was inspected by a lot of different engineers. Nobody went back and looked at the original design drawings that showed that those joints in those spillways, the underdrain, was totally insufficient. If somebody would have looked at that, they would have said, "Whoa, we need to do something." But all the high-quality engineers and engineering firms, nobody picked up on that. Ended up spending over $1 billion so far repairing. So your slabs, if they're not adequate with water stops and not reinforcing steel, they'll pop out. Here's the concrete, looks like it's only like 3 inches thick. Most of the time it's 12 to 18 inches thick. It's supposed to be. Conduits, a lot of different issues with the pipes to the dam, seepage, differential settlement. Talk about some of those. If you're big enough, you can crawl in, but there's a safety thing. That's a confined space. And you should have an air meter and make sure before you start going down into a vault or into a pipe, because you can get into trouble with black box. But if you do the right procedures, this is better than a counter, because you're crawling up in the pipe, looking at every joint, every pipe condition. Here's one where they did not have an adequate plunge pool. You can see the erosion gully that's developing below the outlet of that pipe. Eventually, that'll work back and the end of your pipe's going to fall off. Here's one that's happening today. So now that gully's gotten so big, this last joint of pipe is now starting to fall off into the plunge pool. You can see another joint separation here. So you look, if you get in the pipe, you look at each joint. And this goes back to record keeping. You label the joint, 1 through 15. And then you measure, all right, that joint opening is 1/4 of an inch. 5 years later, it's 1/2 inch. Next year, it's 3/4. If it's doing that, that trend says, I got something happening causing my pipe to separate. Here's a corrugated metal pipe. You see the bottom of it rusted out. And that's depending on the pH and the soil and the water, the life might be 20 years, and I've seen them last 50 years and look almost brand new. But eventually they're going to deteriorate. Here's one where it's a corrugated metal riser with a crash guard, and almost all the time where this vertical pipe connects to the horizontal pipe, that deteriorates first more than anything for some reason. Water starts leaking, creates a whirlpool, and all this soil and upstream slope starts washing out through the pipe. Seen this dozens of times. So that pipe is deteriorated at that joint, and they had a big void. It drained the lake, didn't breach the dam, but it created a big void in the upstream slope. Concrete structures, a little bit about that, particularly spillways. Here's a concrete sheet spillway that's got some bad problems. May not have any reinforcement in it. I don't see any joints. Usually when you do a concrete spillway, it's kind of like a sidewalk. You see joints periodically. But if you don't put in joints, concrete's going to crack. It expands. When it heats up, it expands. When it gets cold, it contracts. If you don't have a joint, it's going to crack. And then if you don't have reinforcing steel and water stop, you get these holes and you start getting water underneath. Someone told me, a guy that works for the Portland Cement Association, he said, hey, if you got a concrete structure and it doesn't crack, call it. Because it's going to crack. You know, you put a lot of joints and you see them in sidewalks. Sometimes they're cracked right next to a joint. But you do your best job putting in joints and all, but generally you're still going to get cracked. Generally, they're not structural in nature. They're just a nuisance. But you got to be careful with it. Things move around. Here, this wall used to be tight together. This part of the wall is starting to rotate away. So that's telling me the foundation is moving. The upstream slope of the dam is moving a little. You just want to be recognized that at one point those should be touching one another. Concrete will fall, particularly if it doesn't have air entrainment in it. 30 years ago, we didn't have it. So you have freeze-thaw damage. If you have, and a freeze-thaw is, if it gets below freezing, then it goes above freezing. If it gets below, that's a cycle. And so in the southeast during the winter, we have a lot of freeze-thaw sites. It gets cold, below freezing at night, warms up during the day. Up in Michigan, they don't have many freeze-thaw cycles. It gets below freezing, it stays there. So that one cycle may be over 3 months. The other part of a freeze-thaw damage is it has to be water there. It has to be saturated. It's the water that freezes. When water freezes, it expands several times its volume. And ice is fairly strong, and it'll start chipping away at concrete. So if you got an old concrete spillway, chances are it has no air entrainment, and chances are, if you're in a freeze-thaw environment, it's going to slowly over time deteriorate like the face of this concrete dam. Then when it deteriorates, you start getting vegetation on the growing. And then the roots of that start pushing the concrete apart. So just keep things in mind, it's a slow process, but over 20, 30 years, it can destroy a spillway. Sometimes you see cracks and you see this white stuff coming out, is efflorescence. You see it sometimes in brick walls too. That's not a problem. That is in concrete, in the cement, there's lime in the cement. And that, sometimes we've got what we call free lime. There's an excess amount. And then if you get a crack, the water coming through, that lime comes out and becomes calcium carbonate, which is a hard white substance. But it's not doing any damage. In fact, sometimes it's a benefit because if you got a crack and water is slowly seeping out, over a year that calcium carbonate will seal that crack and shut that water off. So it's an aesthetic problem, but generally it's not a problem to be concerned with. Here you go, things, the soil moved and knocked over the part of the spillway. So here might have had a nice spillway wall, but there was an instability of that cyclone. Maybe it got too wet, maybe there was an earthquake. But obviously that needs to be repaired fairly quickly before the spillway operates. Concrete dam, we talk all dam leaks. Concrete is not impermeable. It will eventually slowly leak. And even though the leak is very small, again, that's freeze-thaw dam. Because you've got a saturated concrete, you're in a freeze-thaw environment, and then slowly it'll start falling that concrete off. Gate leakage, generally it's not a problem unless you're losing water and keeping your lake from being full. A small amount of leakage around gates is not an issue. On the CD, this is just, there's O&M manuals, FEMA has a dam owner manual, so this CD that I pointed out has a lot of good information on, about animals, how to trap animals, the nuisance animals. So can't overemphasize. They give sample inspection checklists because we all have a checklist. What to look for. Is it leaking, not leaking? Where is it leaking? So be sure to pick one of these up.